This is the video recording of your study guide for Chapter 1's test. Your test will be tomorrow on Wednesday, August the 22nd. Okay, so the first problem on your study guide was the formula we use to model athletic performance is performance equals ability plus random chance. Performance equals ability plus random chance. You will need to know this. This is very important. We talked about this, that in order to have a performance, you have to include their ability plus the random chance that they score or get a time of the performance. Number 2 says, do the following summarize numerical or categorical data. It also asks you to explain. So number A, 2A, says a team's winning percentage of last season. So yes, we're talking about percentage, but what it's really focusing on is the winning. So the outcome of winning is either you win or lose. Therefore, this is categorical data. Because the outcome of each game is win or lose. So for number 2, it says the average speed. So we're talking about speed of a fastball. That is going to be numerical data because the outcome of each pitch is a number. Number 3, it says, in the 2008 regular season, Indianapolis Colts quarterback Peyton Manning completed 371 of his 555 passes attempts, and in his only playoff game, he completed 25 of 42 passing attempts. Use the appropriate graphical display. Okay, so for this problem, they only wanted you to do one graph, but I'm going to show you all three because you will need to know how all three graphs and what they look like. So the first one I'm going to do is a bar chart. Okay. So if I'm looking, he completed 371 out of 555. So if I look at my calculator that I thought I had one on here. Let's see. Calculator. I am going to do 371 divided by 555. So 371 divided by 555. And that's going to give me 66.8% or 67%. I'm okay with using 67%. So his regular season completed passes was 67%. Okay, so I'm going to take a bar for regular season. I'm going to go up to 67%. I'm going to fill it in. So if he completed 67% of his passes, then you're going to find out how many he missed. So I'm going to do 100 minus 67, which gives me 33%. So I'm only going to go up to 33% on this side. And so that is my bars for regular season. Now, for his playoffs game, he completed 25 of 42. So I'm going to do 25 divided by 42. And that equals 60%. So for playoffs, he did 60%. So he completed, and remember, I have to use the same color, same design. I'm going to fill it in. So he completed 60, so that means he missed about 40%. So that is the bar chart. The segmented bar chart is going to look something like this. So instead of having two separate, I'm going to have one big bar for each of the sections. Okay, and one thing I forgot to include is the complete, incomplete. And yes, I know the gray is a little hard to see, which this was 67%, and the other one was 33%, this one was 60%, and this one was 40%. Okay, so regular season, he did 67, so I'm just going to draw where I think 67 might be, and then 60. I probably need to go up a little bit higher here. And there you go. So this is complete, and these are incomplete. 67, 60, 40, and 33. And then the last one is the pie chart. And this one is just a big old circle. And I'm going to have two, so that was a bad circle. So this one is going to be reg, this one's going to be playoffs. And so 67% is probably going to look a little bit like this. 67% complete, 33% incomplete. I'm shading all this blue so you know what the difference is. And so the other one is going to be, what was it, 60%. So it's going to be 60 complete, 40 incomplete. And there again, same color, same design, so that you know which one's different. So those are the three types of types of graphs that we use to display categorical data. So to briefly compare these two performances, all I'm going to say is Manning had a slightly better performance in the regular season. Okay, so Manning had a slightly better performance in the regular season. Now, it says explain in detail how you would use the random numbers to simulate the playoff games where he made 72 passing attempts, assuming that his ability is 67%. So what you're going to do is you're going to let the numbers 1 through 67 represent complete, and 68 through 100 represent incomplete. You're then going to generate 42 random integers and count the numbers between 1 and 67. And that will represent the number of completed passes he had in this simulation. Okay, so the random number generator simulates a player or athlete's performance. So on the second page, problem number 4 says that in the 2008 regular season, Chicago Cubs outfielder Alfonso Soriano hit 28% of his at-bats. However, in the 2008 playoffs, he only had 1 hit and 14 at-bats, which is 7.1%. 50 trials of the simulation were conducted, assuming that he had 14 at-bats and his ability to get a hit was 28%. At the end of each trial, the number of hits in the 14 at-bats were recorded. The results of the 50 trials are shown on the dot plot below. Explain what it means to have the ability of 28%. So the ability of 28% means that if Soriano were to have millions and millions of at-bats in the same condition, he would get a hit in about 28% of them. The key part of this question is that he has millions and millions of at-bats. They have to be in the same conditions, and the percentage of hits have to be the same as the ability. Okay? So that is key to this question. If you don't have those three suggestions in your answer, then you will get it wrong. You have to say that he has to have millions and millions of at-bats. They have to be in the same conditions, and the percentage has to be the same as the ability. Okay? Briefly explain what is provided in the dot plot. This is part B. Part B is in 14 at-bats, a player with a 28% ability to get a hit can have a performance as poor as, oops, I can't spell, as poor as 1, or not or, and as good as 8, just by random chance. Okay, so some key information in this one is that you have to state what the ability was, how many at-bats he had, and the lowest number, which in this case was 1, and the highest number in this case, which was 8. Okay, so that is key information. And you also have to say it's by random chance. So this whole dot plot was thrown together by random chance. Okay, this isn't what happened. It wasn't the performance. It wasn't the ability. It was random chance. So number C. Many people criticize Serrano for his poor performance in the playoffs. So based on the results of the simulation, was the criticism deserved? In other words, is there convincing evidence that his ability to hit was lower in the playoffs? So if I'm looking back at my dot plot, it says he had 1 hit in 14 at-bats. So if I look here, one hit did occur by random. And it occurred more than once. It occurred 1, 2, 3, 4, 5 times. One hit occurred 5 times. So my answer is going to be no. Even though his performance was below his ability, it is plausible that his poor performance was due to random chance. Okay, and because 5 of the 50 simulated performances were at 1 or below. So that is the reason why we can make this statement that no, the criticism was not deserved. So we're always answering the question. Always answer the question. Okay? Was the criticism deserved? No, because there was 5 of the 50 simulations occurred at 1 or below just by random chance. So 5 of the 50 simulations occurred at 1 and below. Now, if they were asking if it was a higher ability, so I'm going to say higher ability. I'm going to come down here and then I'm going to delete it. So higher ability. Then we would want to use that number and above. So if you think his ability increased, you would say that number and above. If you wanted to see if his ability decreased, you would say that number and below. Okay, so know the difference. Okay. So the next question: how many hits would Serrano need to have in 14 at bats to make you believe his ability had increased? So we're looking at increase. So I need to know how many at bats or how many hits he needs in order to see if his ability increased. Well, the highest number that he had in just random a chance was 8. So I need to go at least one more above that. So the answer is going to be 9 or more. Because such an outstanding performance is very unlikely to happen by random, oh gosh, I can't spell, by random chance. Okay, so that was page 2. Page 3 starts off with number 3. Suppose that a tennis player has the ability to hit the ball in play in 70% of his serve attempts. The following dot plot shows the proportions of made serves in 100 sets of 20 attempts and in the 100 sets of 20 attempts. In 200 attempts, in 100 sets of 200 attempts. Which distribution is the one showing the results of 100 sets of 200 attempts? Okay, so it's looking at, they give us 2 dot plots. One is 100 sets of 20, and the other one is 100 sets of 200. Now remember, according to the law of large numbers, the more attempts you have, the closer and closer you get to the ability, meaning the distribution of the numbers will be smaller. So from here, it looks like I go from about 0.45 to 0.95. While here, I'm at 0.6 to 0.8. So because this graph is closer together, I am going to say that the graph on the right is the 100 sets of 200 attempts. Because according to the law of large numbers, the more you increase, oh snap, the attempts, the closer you get to your ability. Meaning the ability was 70%, so most of the dots are closer and closer to 70% for the second graph. Okay. Number 6, it says, in the 2009-2010 regular season, Kobe Bryant made 716 of his 1,569 shot attempts. In the 2010 playoffs, he made 234 of his 511 shot attempts. To compare his performances in the regular season with his performance in the playoffs, the following graph was created. Describe 2 problems with the graph and how it can be improved. Well, the first thing I want to say is, the first problem with this graph is that number of shots. Okay? Do not use numbers. I'm going to put like 6 exclamation points. Use percentage. Another 6 exclamation points. This is very, very important. Okay? His numbers might not be the same for both seasons. Okay? You must use percents. The second thing is that the vertical axis didn't start at 0. So the vertical axis must start at 0, not another number. Now, the second part of this question that I wrote in was knowing all the ways we discussed that could lead to a misleading graph. So the first way that we had discussed was not using 3D images. Don't use 3D. I know they look pretty, but they are very misleading. The second way, which we discussed, was starting your axis at 0. Okay, it might give away that one performance looks different than the other. Okay, another way, I'm going to write down here, is don't use images. Okay, for example, the example we used was a football and then a baseball. Okay, they cover a different area. Don't use them. And the last one I'm going to talk about, that we talked about earlier in the first week of school, second week of school, one of those weeks, is making sure that your bars are of equal width. Okay? So make sure you know these 4 different topics that we talked about here and there. Okay? Make sure you know those. Alright, so this is the study guide for the test. Now, your test is tomorrow. I will give you a couple minutes before class starts to look over the study guide and to ask any questions, but your test will be tomorrow. Study. If you have any questions that you need help on right then and there, feel free to email me. I might not respond right away, but I will get back to you, I promise. Alright? Feel free to watch the video several times if you need to. Good luck, and I hope you study.